Hello, how are you? Fine? Okay, are you getting tired at the second day at Unite? You all want to go downtown for the million bars that we have reserved for you? Yeah? Okay, thank you for being here. I know it's the last presentation of the day, so you all might be very tired, but you're gonna have fun today, so it's gonna be worth it. So we're gonna cover a very interesting topic today, one of the most exciting things for me, which is 2D and animation in 2D. The talk is called Bringing to the Characters to Life with Sprite Rigging Workflows in Unity. We will see what this means in a second. My name is Arturo. I'm a games evangelist at Unity. That's my email, that's my Twitter account. If you ever need anything, if you ever have any question, feel free to reach out to me. I will always respond. Probably I won't have the answer for all your questions, but I will respond at least, so you have that. Okay, so let's start. These are our goals for today's presentations. The first thing, once you walk away from this room today, is that you will be able to understand the pros and cons of the different animation techniques. The other one is that you will learn the workflow on importing, rigging, and animating 2D characters using Unity's tools. And the third one is to understand how the 2D animation and rigging packages fits into a game development workflow, specifically in the Unity setting. But yeah, maybe in your specific case might be different, so you will have the knowledge to know when to use it or when not to use it. This is the agenda for today. It might seem like a lot of content, and it is because it is a lot of content, but in reality, it's very simple. The goal here is not for you to remember all the steps that I'm going to be doing today. The goal is that you know the tools, that you know that those things exist, how they work, and then once you decide to apply them in your games, you can just go to the documentation and implement them yourselves. So, continuing, first way of creating animations. Are you familiar with the frame-by-frame approach? Right? If you are, that's perfect. If you are not, basically, it's an animation technique very common in cartoons and some other scenarios. Specifically in games, one of the greatest examples is Cuphead. Have you played Cuphead? Raise your hands. Okay. Now keep your hands up if you have finished Cuphead. Okay, nobody. Wow. No worries, I haven't finished. It's too difficult. But yeah, what they do, and there's a nice GDC presentation online on YouTube. What they do is hand-drawn animations. They could be hand-drawn or they can be digital-drawn animations. They have multiple frames. Each frame has a slight change, and what they do is they go from one frame to the other frame, and by switching these frames at 24 plus frames per second, we get the idea of movement, right? It's a very common approach. There's a lot of information everywhere about this approach. Now, what we want to understand about this approach is that in one side, you have a lot of control, or the artist has a lot of control over the animation overall, because they are drawing each frame. So they can decide what color on which specific pixel, what to deform on every specific frame. That's good to have more control. Now, the downside, and probably you have noticed, is that you need a frame well, you will have multiple frames for animations. And imagine you need to have multiple animations, and the size of the memory required to run your game increases. In some cases, you don't care, but in most cases, you care, right? One, because your build is going to be larger, but if you're running, especially mobile on mobile devices, that means you need to allocate more memory to represent these animations. Okay, on the other side, we have this other approach, which is the skeletal-based animation. Now, instead of having each frame instead of having multiple frames and one sprite per frame, what we have is a drawing, Okay, divided in multiple pieces, each piece representing one part of the body or one part of of a piece in a. I'm not going to say character because you can use these for other things that are not characters. But then you have these pieces, and what you do is you create a skeleton, and then you tie the bones in that skeleton to each one of those pieces. So if you move a bone or a hierarchy of bones, then you will be moving all the pieces attached to that bone. So this is another example, flipping that using this approach. Now, a small exercise for you. Let's imagine we're creating this game, right? It could be I don't know, a farm simulator for mobile devices, and we have this character. This character is a character that is going to be explaining us our goals, our tasks, our etc. This character needs a lot of animations, and this character in particular has to be updated every time a new season comes, right? So if it's Halloween, we want our character to have, I don't know, the face of a pumpkin. If it's Christmas, we want this character to have a Santa Claus hat, etc. So this is what we want to achieve. Which animation technique should we use for this particular case? Just take a couple of seconds. You maybe have the answer because of the animation style that you can see here. But okay, instead of just giving the answer, let's think why we are selecting this answer. The answer is, okay, a skeletal-based animation. Why? Because we're having a lot of animations. So, and it's a mobile game, so I don't want to have 50 megabytes worth of textures just to have all these characters' animations. So imagine the next season, I want to have the hat, and the only thing I'm replacing is the hat. I'm not adding any extra animations. So if I were using the frame-by-frame approach, I will need to basically duplicate all the files that I have in my project. If I'm using skeletal, I already have information about where the head is. I could simply attach another sprite to that bone in particular. So that's good. I just have this character once, and this is important. Why? Because these animations are being evaluated in the CPU. Okay, so yeah, while I'm using less memory in most cases, I'm using more CPU in general. Okay, so this is the first example. Now, this example, this is another game. Imagine some things are happening on the foreground, and we have these dogs walking on the very background. They are not doing anything besides just walking. I'm not going to be able to interact with them. They're just moving from one side of the screen to the other. Which technique, and by the way, we will have a lot of these dogs walking there. I'm not sure how many we have there, tens or something. Which technique should we use in this case? Skeletal or frame-by-frame based animations? Now, again, take a couple of seconds. You maybe have the answer. The answer here is, for runtime, we're using a frame-by-frame approach. Why? Because we don't want to have the CPU evaluating animations every frame, right? We just want to have a copy of all my textures for the walking animation, may have just 3 or 4 frames, and I can just replay it everywhere in the background. And I'm not pushing more stuff to the CPU, which is great to have. Now, in this particular example, what I'm doing is taking kind of a hybrid approach, because to animate the dogs, I'm actually using a skeletal-based approach. But instead of just evaluating the animations, what I did was I exported those animations as frames, so I have them as frames, and I'm using a flipbook approach. So it's kind of like a hybrid approach, but the actual animations were made, are being run using frame-by-frame approach. So what can we achieve with this way? Are we tied to a specific type of character, or can we do anything we want? And the answer is, basically, we can do whatever we want with the skeletal-based approach. Like here, we have a humanoid character, a very organic character. We can have more complex characters, kind of giving the idea that we have 3D going on, although we don't have it. And we can also have characters that doesn't necessarily remind us of any particular object, like characters that have a neck that is made out of a cable or a rope with multiple legs, etc. And this character is the one we're going to be using today for the demo. Okay, so how do we start? The first thing we need to do is we need to open the package manager and make sure that we have the 2D animation package. As most things in Unity, these packages are free. So if you're using Unity, any version, you can just go ahead and import that package. So I went to the package manager, 2D animation, I installed the package. As you can see here, I'm also going to be installing all the dependencies that I need. In this case are 3, the 2D Common, Mathematics, and the 2D Sprite packages. So as soon as I install this one, I will also be installing the rest of the dependencies that I need to install. So there's the first step. Now, the second step is importing the file with my character. I need to import the actual sprite or the actual PSD file that I need in my project. Now, for this use case in particular, we won't be using a PNG or a JPEG or even a PSD file. What we're going to be using is a special type of Photoshop file with the extension PSB. So this is something that we need. The V stands for big, so it's a Photoshop file that is bigger. Okay, so if I just simply go to my Files Explorer and I import a PSV into Unity, the same way we always import our packages, Unity won't know what to do with that file. It's just going to be there, but Unity doesn't know how to manage this file. For that, we have another package. And this is the PSV file. So you can see that everything is separated into different layers. Each piece of my robot is separated into a different layer. Automatically, the PSV importer is going to detect that and is going to generate one sprite for each one of my layers. So just be careful not having a pixel with a color somewhere else in that layer. Otherwise, Unity will try to make a larger sprite. Just be careful about that. Okay, so this is how it looks. I can deactivate all these layers once I export this PSB I import this into Unity. All the invisible layers won't show up there. Okay, so I go to the package manager. I now need to install the 2D PSD importer package. And as soon as I do that, Unity will recognize this PSB file as a regular sprite. So if you see here in the inspector, now I can open the sprite editor. I can configure how I want Unity to import the file. And you see here that I have my sprite editor window. Unity automatically generated all the sprite pieces for me, so I don't have to do anything else. And the next thing I have to do is start with the actual skinning. So inside the sprite editor, once I have my 2D animation package, I will have more tools that will allow me to create my rig and to weight some bones with meshes. But just let's take a moment and understand the workflow for animating or creating our animations in Unity. It's basically 3 steps to create something that can be animated. And it's hand by hand with the options that we see on the sprite editor window. The first step is we have to create a skeleton. We have to define what's the skeleton of our object. The next step is we need to create a mesh. We need to create geometry. By the end of the day, most of the things that we see in Unity are meshes, right? Are just collections of vertices connected together, creating triangles. So in this case, even if we're using a 2D approach, what we're rendering at the end of the day is a mesh. And this is also important because if we have more vertices, if our mesh is more complex, we will be able to have certain type of animations. If we decrease the count of vertices that we have, we will not be able to achieve certain type of animations, or the quality will also change. So just keep this in mind. And the third step is linking the bones that we created in the skeleton with the vertices we created in the mesh when we created the mesh. So let's see how this all works. You see here that I'm on the same Sprite editor window. I'm on the bones section, and what I'm going to do right now is I'm going to start creating my skeleton. Super simple. If you have used other similar tools to create these skeletons, the approach is basically the same. It's pretty straightforward. If you're not an artist and you're new, who here is an artist? Raise your hands. Oh, a lot of you. And who is not an artist? Okay, I will say 50-50. So that's good news, because if you're an artist, you can create awesome stuff. If you're not an artist, you still can create stuff. So that's great. Okay, so I'm here. I'm going to start creating my skeleton. So I selected the Create Bone option, and I'm just starting clicking on top of my sprite. So for some parts of my sprite, of my character, I'm adding more bones. For some parts, I'm adding less bones. And this decision has to be made by the animator. And the animator and the person who wrote who drew the character. And why? Because, for instance, in the neck, we want to have like this effect of a rope, so we want it to look more like organic. For the head, for the two pieces of the head, we don't want it to look like very organic. We want it to look like just two pieces doing this effect. So another thing to consider is the more bones that you add, the more CPU usage you will have. In some cases, you won't care. In some cases, this is important to know, right? Like if you have a super small element in the background that is repeated 1,000 times and has a lot of bones and nobody noticed that, and somehow the game is running at 10 frames per second, that might causing the problem. Okay, but anyway, what I'm doing here is I keep creating my bones. You can see that every new bone that I create is linked to the previous bone that I added. That doesn't mean you have to work this way, and in fact, most of the time you are not linking all the bones in the same hierarchy. You can go back and tell the system, okay, I want this. Let me show you here. I want this bone to be parented, not to the last bone that I created, but the bone that goes before that one. So you can do that. How do you achieve that? You simply have to click Escape, and you're good to go. Okay. So I keep adding these. In some cases, I can add some extra bones. For instance, for this thingy, I forgot the word, the spring. I may add a couple of bones. You can add just one, depending on the animation. I could add more to have more detail, but depends on how far am I going to be seeing this character, because if the camera is going to be too far, maybe I don't need that detail, but depends on what you want to achieve. For the legs in particular, I just have one bone per part of the leg, because I want this effect of elements being made by metal, so I don't want them to be too organic. So I keep doing this. I'm gonna go ahead, but this is the process of how to create these bones. Depending on the complexity of your character, you will have more or less bones. Now, I think it's worth explaining to you that to get good animations, you need to know about animation. It doesn't really matter the software or the tool. It's going to help you, but to know the real number of bones that you need, you will need to know about animations. You will need to know, like, okay, I need more bones in certain parts, less bones in certain other parts, etc. So I will keep creating my skeleton here. I'm not gonna do it right now. By the way, it's not that I am a magician. It's just that these are videos, okay? Because you see me moving my hands and then Unity is moving. It's not. Okay, so let's continue. Now, I have my skeleton here. This is the first step. The skeleton is a hierarchy of bones. What that means is that if a parent bone, meaning the root bone, moves or translates or scales, the rest of the hierarchy is going to inherit those transformations. Okay, so if I rotate this bone, the rest of the bones are going to rotate with that. Okay, this is simple, but it's important to remember about that. Now, by default, these are not, if I move the bones, they are not going to move my sprite. Why? Because this is just a sprite. This is just a texture. We need mesh. We need a mesh that we can transform with those bones. So what I can do, I can use the auto geometry button, as I'm doing here. And you can see that the package already generated a mesh for me. It's not necessarily super optimal, but it's a great starting point. Because if I was to create the mesh by hand, which I can, it will take me a lot of time. Depends on what you want to achieve. But I think it's better to start with the auto-generated approach and then just go and edit the geometry. For instance, on these antennas, I might have a lot of vertices, so what I could do is start removing some vertices, right? Because they are too small, they might have a lot of vertices, they might be moving, but moving so many vertices is going to be more expensive, so I can remove those vertices. On the other hand, you might say, oh, I want to have a special effect on the antenna, so I need to add more vertices. That's also something that you can do. Besides modifying the vertices, you can modify the edges as well. Also, you can notice here that each mesh is divided. Each is generating a mesh per sprite that Unity saw in my file. So I have multiple meshes in particular, and this is important to know. So here, what I can do is I can add more vertices here because remember, I want to have a more organic animation. And in general, this is one rule that some artist, some animator told me, is that in parts of your skeleton where you will have like objects doing this movement, you probably want to have more vertices there, just to improve the quality of the animation. Everywhere else, you can remove some of them, but again, depending on what you're trying to achieve. So as I did this, you probably already noticed that the bones, when I created the geometry, the bones were tied to my geometry, which is great. The link now is not perfect because it was also done automatically, which is great as a starting point, but we need to go back and clean up a bit. Otherwise, we will have weird animations. So here you see that I'm just creating more edges, splitting edges. These are just tools to improve the quality of your mesh. Improving the quality doesn't mean adding more vertices. It just means making something better for your specific use case. So in this case, actually, in the trunk of this character, I could go ahead and remove more vertices, but let's just leave it as it is right now. Now, the next step is telling. Remember, the package automatically assigned what we call the weight of each bone that has over every mesh. Now, what I want to do is paint those weights or tell my mesh, my vertices, which bones will affect them. What does this mean? So every bone has a color here. You can see that they are color-coded. Every bone will have some influence over every pixel, every vertex in my mesh. For some of them, the value will be 0, which in reality means they don't have any influence over them. But this is the idea. So if a bone moves, and this bone has an influence of 1 over certain vertices, those vertices will move with that bone. If the influence of a bone is 0 over certain vertices, if the bone moves, those vertices will stay quiet, will stay there because the bone doesn't have any influence over them. So that's how it works. You see here that the auto-generated weight is taking place here. So if I move one bone, I'm actually also moving the rest of the hierarchy. But I get some weird effects such as this one. right? Like, I don't want my character to look like it's made out of plastic. I want this to look like it's made out of steel or any type of metal. So there's something weird here, and we need to fix that. The way we can fix it is modifying the influence of bones over that particular mesh. So we have also some visibility tools. So in this case, I just modify the color just visually. And let's go back to my mesh. So you can see here that the mesh has multiple colors. I have the color of this, one second. The color of this bone, mostly on the top of the mesh, and I have these bones here, the color of these bones, kind of influencing the lower part of my mesh. This means that all these bones have some sort of influence over the mesh that I have here, which is not what I want. I want just this bone to have influence over the entire mesh over here. So what I'm going to proceed to do is remove the bones influence from my object. So for that, I simply go to weights, bone influence, and you can see here on the lower right part of my window that I have a list of all the bones influencing that mesh. In this case, I just need to delete all those bones so they don't affect my mesh in this case. So I just select them, click the minus sign, and I can multi-select and just get rid of them for once. But I just wanted to show you how this works. This is a process that takes some time, and in reality, it does take some time because it's like a handcraft. For some big meshes like this one, it might not be that bad because it's pretty obvious which bones I want to influence the mesh. But on some other parts, it's going to be trickier. So for instance, I have the same issue, and you can even notice how the shadow is being deformed. This is not something that I want, but this is what was automatically generated for me. So what I need to do is go ahead, click over every piece of my sprite, and I need to make sure that those bones are correctly tied to my mesh. So in this case, it's the same thing. Now, instead of going to the bone influence window, as I was doing before, now I went to the weight brush, and I'm going to be painting the influence of each bone over my mesh. So it's quite simple. I just need to select the bone, and I start painting the influence over each one of these vertices. It looks like it's defining the weight over the actual mesh, like on a per pixel basis, but in reality, it's doing this on a per vertex basis. Okay, it's just like the color thing. Okay, I keep doing this. What I'm gonna do is just keep doing this for my entire model. For saving some time, I'm just going to go ahead and fix one thing, one issue that I had with my rig. The issue I had is that I forgot to add a leg of my character. I was not paying a lot of attention, so I forgot to add one leg. At any point, I can go ahead and create more bones in the structure. As long as I haven't, if I'm adding more bones, it's okay. It's no problem. As long as I don't have any animation, it's also okay. But if I have animations and I'm going to remove bones, then you have to be careful because those vertices now won't have the influence. So you will might be losing information, and the animation will probably break. So again, I'll keep doing this thing. I forgot to add that part, and let's continue. Now, what I'm going to, to do is actually animating the skeleton that I did. I have my rig, I painted the weights, everything works perfectly. I fixed already all the errors that I had. How do I do this? Well, it's super simple. I just need to take my object, which is now seen as a prefab. I drag and drop it into my Unity scene window, and I can use it as any other game object, because even the bones are going to be just regular game objects. If you have used animation tools in the past, even Unity's animation tools or rigging tools or external tools, you will always end up like doing special things, not like just using game objects. So in this case, it's basically just game objects. So in this case, I can do all the stuff that I usually do in Unity with regular game objects. And for the actual animation, I'm going to use the animation window. So at this point, you might be wondering, why the hell did you import an animation, a 2D animation package if it's not for animation? And the answer is, I don't know. But the good thing is that we can use the same animation window we all know and know how to use for years now. So I open the animation window. I go ahead, dock it somewhere here. I will create an animation clip, the same type of clips that we've been using forever. I'm going to save it somewhere in my computer. And the next thing I'm going to be doing is creating my keyframes with positions for my bones. So what I will be animating are the bones themselves, not the position of my mesh. The mesh is driven by the position of the bone. What I'm going to be animating is the position, well, the transform of my bones in the skeleton. And remember, since they are part of a hierarchy, I will just need to move like the parent of any section of my hierarchy, and the rest is going to be moving. So you see here, I want to make like a roar animation. What I do is I just rotate the root of the neck and then the tip of the neck. I open the mouth, and you can see here how Unity, as usual, is just saving the keyframes. So it's going from frame 0 to frame 30, and the interpolation is managed automatically by Unity. Now remember that this interpolation is being done in the CPU, so even when minimal, this is taking some CPU cycles. If you just have one character in your game, it's fine, but if you have multiple characters, then this might be an issue. Just consider this, okay? So I have this animation, and I'm ready to go. I have an animation clip that I can use it. I can use it with Timeline. I can use it with all the other tools that we know and love. The next thing is, now I have my skeleton. It's already animated. But imagine I want to animate, I don't know, the neck of my character. It's not going to be fun, and it's not going to be a work anybody wants to do, to move all the small bones in the hierarchy and make some sort of stop motion animation. This is maybe not something that we want to do, especially for certain type of characters. So we can use one technique called inverse kinematics, which basically means we will define a target for our skeleton or parts of my skeleton. And as we move the target, the defined part of the skeleton will try to reach out the target. It's called inverse because unlike the forward kinematics where this bone moves and then this bone moves and then the rest of the bones moves, in this case, the last bone is going to move first, and then is going to define what are the positions and rotations for the rest of the skeleton. So this is what we're going to do here. Instead of doing manually the animation of the leg, for instance, we're going to use inverse kinematics. That's another package, and this is probably the 4th package we've installed so far. I think this is great because if you're not using inverse kinematics, then you don't have to install this package. If you are, then you have to install it, but it means we're delivering a Unity that relies less and less on specific packages for work, right? If you don't need any of these tools, then you can go ahead and you won't be paying the cost of processing stuff or having a larger download file when you download Unity. So what I'm going to do is import the IK package from the package manager. It's called the 2D IK package. I simply install it. It has dependencies on the 2D common package, and that's the only thing. Now, how do I create my IK? The first thing I have to do is go to the root. I'm going to create an IK 2D manager, and then I have to create a solver. This solver basically is a component that will allow us to tell what to do with the hierarchy of our bones. In this case, I will use a limb solver. We have 3 types of solvers, 1 limb and 2 flavors of chain solvers. In this case, I just want to animate the leg, the first 2 bones in the leg of my character. So for that, I need 2 objects. One is an effector. To create this effector, what I need to do is go to the tip of the hierarchy for that specific part. I will create a game object, and I have to place it at the very tip of my bone. So I put it somewhere there, and then I need to create a target. The target is going to be a small gizmo, and it's actually a game object that you can use at runtime, which is great because we'll see why it's great in a second. But yeah, it's going to be another game object. You can create it manually, or you can simply tell the package to create it for you. So you can see here, do you see a small gizmo over there, a small circle? Yeah? Okay, now I'm moving the gizmo, I'm moving the target, and the hierarchy is moving. It's trying to reach that target within its constraints. So it cannot enlarge itself. It's just constrained, but it's going to try to reach out that target. Now you can see that there's something weird with how it's flexing. It's a simple fix. I just need to tell it to flip it, and then the rotation is going to be made the other way. So it's very simple. I will need to go ahead and create everything for the other legs. Now I'm going to use a different type of solver. In this case, it's going to be a chain type of solver. This is useful if you want to simulate chains or ropes, etc. Elements that includes hierarchies that are more complex, that have more than two bones. The process is similar. I will select the last bone in the chain. I will create an empty game object. I'm going to place it at the tip. I then will go and select the new solver. I'm going to assign the effector and then automatically create the target. Now here I have to count the number of elements I have in the chain, just because this is the way it works. I have a lot of values here that you can define. The higher the number are on these sliders, the more realistic the animation is going to look, but it's going to take more processing time. Just take this into account. So if you play around with the value and you don't see any noticeable difference, then probably it's better to just keep the number low. Okay, so I do that, and you can see that if I move my target, the entire hierarchy moves, which is great because now you just need, you probably just noticed that instead of having to animate or position on every keyframe the bones, you just need to position the targets, and then the skeleton is going to just follow the target there. Okay. Now, to wrap up, there's another interesting feature that we have. Since we are using this skeletal-based animation, as we saw in the demo with the farmer girl, sometimes we want just to replace some parts of our sprites, right? In this case, imagine this character can receive damage, and instead of just applying a generic damage, we want to apply damage to the pieces that are actually receiving damage, right? So if my character is receiving a lot of hits on the head, then I want to replace that sprite to something that resembles some damaged metal. So I have 2 versions of my sprite. 2 PSV files. They have the same layers, they have the same names, they have the positions of the sprites, of each sprite at the same position. You can see Unity is importing them. The atlas looks different. It doesn't really matter as long as they have the same names and layers, etc. And you might be wondering, okay, do I need to recreate the skeleton again? And the answer is no. You just need to copy and paste the skeleton you previously had. So I select all the bones, I click copy, I go to the second one, I select the bones, I click paste, and both will now contain the same hierarchy. This means that I have two objects with the same hierarchy. This means I can simply recycle the animations, and you can do that. Now, this is not what I wanted to achieve. What I wanted to achieve is to replace certain sprites in the certain meshes or sprite renderers in my object. So I need to create an asset library just to hold the information of what different sprites I will be using. So in this case, I created this library. It's just a regular scriptable object, and I have to create categories. One category is going to be for the head, another one for a leg, another one for the eyes, etc. You will be creating multiple of these, depending on which sprites you want to swap. And you just need to select which sprite is going to be used when you are in the normal state. As you can see, I define them as labels, and which sprite you want to use for the damaged state. Okay, now I need to go to the object that has, I need to go to any object in the hierarchy, and add a sprite library component, which is going to link the sprite library asset that I just created with my game object. I just need to assign it to it. Now I need to select the sprite renderer that I want to be swapping sprites, and just add a sprite resolver. And simply, I just need to tell which category I'm modifying, and loop through one or the other. You saw there's a slight mistake there. The problem is the pivot on my second sprite was not at the same position as the pivot on the first one, so that's why I was getting this offset. But now I fixed that thing, and I can swap between both sprites back and forth. Another cool thing is that this works at runtime as well. So you can make these changes via code at runtime, or you can just swap the sprites in the animation window. It's very, very, very flexible. Now, before you go, just remember that the package will be verified in 2019.3. You can use it right now, but it's in preview. It's coming, it's being verified. If you have questions, if you have feedback, please come to the forums. They are always being monitored. We're happy to receive more feedback. Please post your animations on Twitter. If you're using Twitter, use the Made with Unity tag. If you want to talk more about 2D stuff, come to the 2D kiosk tomorrow. Tomorrow's the last day. I won't be there, but whoever is there is going to have fun talking to you. If you want to learn more, please go to or subscribe. There's a 3-month free trial at unity3d.com/learn-premium. There's a code, or if you are following the Humble Bundle updates, they just announced some sort of promo with Unity, so you can also get access via the Humble Bundle. Now, thank you very much. I hope you enjoy Unite. If you have questions, please meet me outside, because I don't think we have time for questions. And hope you have fun tomorrow and tonight at the party. Thank you.